I'm going to work with your packet today, question number 7, which is, I think, on page 3, talking about the 10,000-pound object suspended on a wire tied between these two poles. And they give us a nice diagram here of where the angles are. There's a 22-degree angle here and a 49-degree angle here. And what they want us to find is the tension in the cable to each pole. So what they're asking for is the magnitude of this vector and the magnitude of this vector. So we actually have two unknowns here. So a tension is the same thing as the magnitude of this vector. The tension of this, magnitude of this vector. What we have here is 3 different vectors because we have this 10,000-pound object, which 10,000 is the magnitude of the vector going in a directly vertically down. It really should be drawn very long because 10,000 is quite a long vector, but they're just going to show it like this. What we have here is a system in equilibrium, which means that this weight is not moving left or right. There's nothing moving here. And if you add this vector plus this vector plus this vector, the sum of the 3 vectors is equal to 0. Zero comma 0. So what we're going to do is we're going to set up a system of equations that when we add these 3 vectors together, we want to get the result of 0, 0. Well, how are we going to do that? First of all, we'll call the magnitude of this vector A. I'll call the magnitude of this vector B. Those are the 2 unknowns that we're solving for. This vector has an angle of 49 degrees, so we'll call this vector 1. Vector 1 is A, the magnitude, times a cosine of 49 degrees, A times a sine of 49 degrees. That's vector 1, or wire 1, cable 1. We have cable 2. And this angle being 22 degrees over here, if you actually draw this in standard position, this is a 158-degree angle. So this vector in component form is B times a cosine of 158, B times a sine of 158. And then we have this third vector coming down. I'll call it V3 for vector 3. Vector 3, 10,000 is the magnitude. Cosine, and this angle here, if you go all the way around to this vector, it's 270 degrees. And 10,000 times a sine of 270 degrees. So when we add these vectors up, the result should be 0, 0. So we'll set that up like this. A cosine 49 plus B cosine 158 plus 10,000 cosine of 270 should be equal to 0. A sine of 49 plus B sine of 158 plus 10,000 sine of 270 should also be equal to 0. These are just constants, cosine of 158 and 49 and 270. And so I'm just going to plug those into my calculator and get those decimal values. So the cosine of 49 is 0.656059. I guess I'll just use that much. So these 3 things go to 0.656059A plus, now let's do the cosine of 158, should be negative, yep, negative 0.92718. So I'll just change that plus to a minus 0.92718B plus 10,000 cosine of 270 Well, I know the cosine of 270 is 0, so it's just plus 0 is equal to 0. And down here, we'll do the sine of 49, which is 0.75471. A, and the sine of 158 is 0.37461 B, and I know the sine of 270 is -1, so this is minus 10,000 is equal to 0. Well, this is nice because that plus 0 can go away, and what I can do is add 10,000 to both sides of the equation here. So I'm going to get rid of this equals 0 and just set it equal to 10,000. And now we have a system of equations, 2 equations and 2 unknowns. And we'll just solve for one of them and then solve for the other through substitution. Well, I'm going to take this first equation here. So with this first equation, we can set 0.656059A equal to, because you can just add to both sides of the equation, 0.92718B. And now we can solve this for A by dividing both sides. So A is equal to 0.92718 over 0.656059, dividing both sides. And so we're going to take this and substitute it in to the other equation. So we can solve for A, and then we can solve it for B. Or actually, we'll solve it for B first, and then we'll solve it for A second. All right. So taking this second equation, this is just solving a 2x2 system of equations, we'll put 0.75471A, but A is really 0.92718B over 0.656059 plus 0.37461B is equal to 10,000. All right, so we have like terms, but we can just do this multiplication, add it to the 0.37461, and then divide 10,000 by that answer, and we'll solve it for B, and then we'll go and substitute it in for A. So let's hope we got all the numbers written down right and haven't made a mistake along the way here. So here we go, 0.75, and you should do this along with me, making sure that my calculator, making sure my numbers match yours, or you can do the same thing that I can do. So here we go, 0.75471 times 0.92718 divided by 0.656059. Okay, and you add that to 0.37461. So there's your coefficient of B, 1.349, etc. B is equal to 10,000. 1.349, etc. B is equal to 10,000. So to solve that for B, you just do 10,000 divided by that answer. And you get 7411. Looks like I had a parentheses issue when I used my calculator. I didn't close up the parentheses, and it should be 1.44121. B is equal to 10,000. And if you divide 10,000 divided by 1.4412, you get B to be 6,938.6, I believe. 10,000 divided by that answer, 6,938.6. So that would be B, and B is the tension on this cable over here. And now to find the tension on the other cable, which is cable A, all you have to do is use this formula that we've boxed in and substitute 6938.6 in for this B. And when you do this multiplication, you're going to get cable A has 9,806.0 pounds of tension on it. So those are our two answers. Find the tension in the cable to each pole. So we did that. And remember, it was just an equilibrium problem, setting each vector, the sum of the vectors equal to 0, and using a system of equations. These decimals get kind of messy. I took them out to 5 decimal places. But it's probably just as easy if you store values into your calculator. Maybe you could call them A, B, C, and D, or whatever letters. You have 26 letters to work with in your graphing calculator for storing. Then you don't have to worry about mistyping anything or maybe even having parentheses issues. Looking at the rest of this, and it looks like we pretty much covered everything. I was going to do number 17, but they didn't give us any angles to work with for the 2 cranes lifting an object. It's just like the one that we just did. So on Monday, hopefully I'll define some angles that we can work with, and we can figure out number 17. And number 15, or number 18 on the back, it doesn't give enough information, I don't think, to complete these problems. So that's about it. I think it's a short video today, and hopefully you've had a good weekend.